Hey, friends. Woo! How are you, sir?
I'm doing very well. How are you?
I am very well. Are you excited for a highly technical talk? I'm so shocked that they let us put that in the title, but I'm feeling pretty excited.
I am too. I don't know what it means, but I'm very excited for it.
I wasn't sure whether the quotes implied that it's not technical at all.
Highly technical.
Highly technical. So I am Scott Hanselman, and this is the incomparable Stephen Tobe, who has been doing Deep.net. Big hand for Stephen. Stephen called a couple of months ago and said, I've just got so much .NET, I just want to get it out to the people, what can I do? And I said, call me, and I'll push record. And we've done 5 fantastic episodes of Deep.net.
More to come, right?
More to come, and we're going to start to include folks from all over the .NET ecosystem, and they're going to be sharing their knowledge as well. But we're going to consider this a live taping.
Absolutely.
Of Deep.net, and we'll end up putting this video up on this playlist as well, and it'll be, of course, available on demand at build.microsoft.com. Cool. So let's go into it. Demos.
Awesome. Yeah. Right. I'm sad you were 0 minutes to demos yesterday.
I know. This was like 30 seconds to demo. It's unacceptable.
It is unacceptable. A bunch of the comments on the Deep.net were about things like specific topics, but then also how do you do what you do, right? How do you find these performance optimizations? How do you figure out what you want to talk about? And so what I thought we would do here today is actually improve something. Right? So on the way here, on the plane on the way here, just before I got on the plane, this is moving. I was exploring NuGet, looking for really cool projects that we could look at, and I grabbed Humanizer. Humanizer is a project. It's super popular. It's used all over the place. It's had like 50 million downloads from NuGet. It's used by Roslyn. We can even see what it does with Roslyn. If I have a class called Person, for example, and then I say list of person. You can see it suggests people. Yeah. Right. That's Humanizer. It's basically
the picking of the word.
Picking of the word people. It's not person.
That was Copilot, but people was Roslyn.
This is Roslyn.
And that's Humanizer. And Humanizer is Claire Novotny.
It is. Yep.
And she did that. So big hand and big shout out to Claire for letting us use her library.
Absolutely.
50 million downloads.
It's huge, super impactful. But the key thing is, across the ecosystem, no matter what library you're talking about, there's always room for improvement, including my own. I wrote a fairly lengthy article each year on the improvements to my own code, right? Everyone has opportunity for improvement. So I have not changed the code in Humanizer at all yet. Okay. The only thing I've done to make my life a little bit easier is it multi-targets all the things, Net 8, Net 7, Net 6, Net Standard, whatever. Right now, I just changed that to just be Net 8, so I don't have to worry about download.
So for now, we're going to optimize Net 8 for the purposes of a 45-minute talk.
Exactly. So there's a lot of varied functionality across Humanizer. Let's just take a look at a very simple thing that it does. One of the things that it does, I can just go up to my console.write line here. It's got a function called truncator. And I can say truncator. For example, fixed length. And then I could say truncate, and I give it a string like, hello, build. Ooh. Hello, build. This is not my keyboard that I'm used to. How are you? And you give it a length that you want to truncate it to, like 8, and then what you want it to truncate with. And if I run that, Control F5, where's F5? It builds, and you see it truncated it to just the 8 characters from what I was saying.
Yeah, right? And that's stuff that we do all the time. We're always, and then you got to go and write index of, and from the left, from the right. It's very human in its API.
So anytime you're looking to make something faster, you first need to understand where you are, right? Mm-hmm. So let me zoom out just a little bit. I'm going to take this call here, and we're going to use benchmark.net to sort of understand what we're doing. So I'm going to write a public class tests. I'm going to add a function. We'll just call this public string test and paste in Control V. The same code that I had. Now, to make this work with benchmark.net, I'm just going to add a benchmark attribute to this. And then I come up here and I say benchmark switcher dot from assembly with type of, wow, this keyboard is hard.
You want to switch?
I do.
Yeah. I'm going to go like this and pretend it's me.
It's perfect. From assembly type of tests dot assembly dot run args. And we can run that. Actually, before I do that, I'm going to add a couple attributes to my test class. One of them, because we have limited time here, I'm going to tell it to only do it more quickly than it would normally do. And I'm also going to ask for some memory information,
Right.
things like amount of allocation, GCs, and so on.
And we talked about benchmark.net before. You can see that there's no public static void main there. It's all implied by that run, and it's pulling it. It's a test framework for performance, and it's testing it on that current type, and it grabs the assembly name from that type.
Exactly, and you can see what it did here. It built a simple application that included my test, and it's running it, and we get results really fast saying that each invocation took about 15 nanoseconds and allocated 96 bytes.
Nanoseconds.
Nanoseconds.
Not milliseconds.
Yep.
Okay.
Billionth of a second.
Billionth? Millionth?
Billionth.
Billionth.
Yeah.
That's a lot.
Yeah, it's a lot.
Very,
I think. Am I math right? I think so. Billionth.
yeah.
So
It's not a picosecond.
that would be more than that.
Yeah.
Yeah. So we're gonna, it took 15 nanoseconds. That's pretty fast, but we can do better. The interesting thing for me,
Pretty
though,
fast.
was the 96 bytes. Because,
The allocation.
yeah, because this was HELLO ... So 8 characters, 2 bytes apiece in .NET. That should be 16 bytes plus a little overhead for the string object itself. 96 is more than that.
A little excessive.
So what I want to do is profile this to understand where is that coming from. So I'm just going to write a little loop here. We'll say I is 0, I is less than 10,000, I plus plus. I'm just going to make this easier for myself later. We'll just say tests t equals new, and then here I'll do t.test. And so what I'm doing here is I'm just setting up something for the profiler to profile. And I'm doing it 10,000 times because I want to make sure that there's a fair amount of allocation that happens at .NET Application Startup, and I just kind of want to be able to separate the signal from the noise.
Okay.
So now we'll profile this. I'll go to Debug, Performance Profiler. There's a whole bunch of profilers here that are hard to see. There's a CPU usage profiler, there's file I/O profiler, and there's an allocation profiler. That's the one I'm going to choose.
And all of this ships now and has shipped for years. And you should think about this as the audience. What percentage of you use the debugger every day? And how many times do you use the debugger every week? And how often have you spent real time in the profiler?
Right. And so the interesting thing we notice now, because I use 10,000, basically we're going to divide by 10,000 to figure out what's happening in each of these. And you can see that there are these 2 allocations here, or 2 lines here. So we're allocating 20,000 strings and 10,000 of these fixed length truncators, which is a little strange. That's 3 objects per call when I was sort of expecting just 1 for the string.
Okay.
All right? So let's figure out why. Now, if I double-click on the allocation I care about here, you can see the backtrace for where it came from over here. We can see it's coming from my test function. Now, I didn't actually have a call to that in my to that allocation in my test function. What happened was something got inlined into my test function. And so if I go to see what that was, I'm going to go to the fixed length property. You see any issues?
Yeah.
Yeah. Every time I'm accessing this property, it's allocating a new object. Now, there might be a reason for that. It might be that this object is stateful, and we don't want to give back things that from multiple threads might be mutated in some way. But if I go and I dive into this object, I can see that there's no state. It's just a function.
Right. So that static class is becoming effectively a factory class without maybe intending to.
Exactly. My guess is whoever wrote this intended for it to be the equivalent of semicolon that, the equivalent of that, right? And if we were to profile again just by that one change, we've now cached this this effectively immutable stateless object so that we don't pay for that each time.
Okay, and then this new syntax here, though, this is fairly new C#.
Yeah, it's a few years old. Basically, it's the C# compiler. It's called an auto property. The C# compiler is creating a backing field, a read-only field of that type. In this case, a static read-only field of that type. It's initializing it to this object, and then this fixed length property is just returning that field each time you access it.
Very nice way, clean way to get a backing field without having to see it and use up a bunch of lines.
Exactly. So now the other 2 were coming from this fixed length truncator, and we certainly expected this to allocate a string because I was asking for it to create something new. The signature returns string. But why was it producing 2? Well, we can see the default here for truncate from is truncate from right. I could have changed that, but if we scroll down to the code that handles truncate from right, you can kind of get a sense for where these 2 allocations are coming from. This plus here is exactly equivalent. In fact, the C# compiler will translate it into this, exactly equivalent to having written instead string.concat.
Right, because
those-
the plus is an operator, and the operator is an operator overload. It is a syntactic sugar for string.concat.
Exactly. And so the C# compiler lowers it into the equivalent of this, and now we can see where those two allocations were coming from. We're creating a new substring, and we're concatenating this. Now, we need the concatenation, because this function needs to return a string. But this substring is pure overhead. Now, when this code, I looked to see when this code was written. This was written 10 years ago. And 10 years ago, that's as good as you could do. Today, we can just say ASSPAN.
And this is a really, really important point. These are smart people. They're great sports, you know, whether it be Claire or Simon and all the folks that worked on Humanizer. It was as good as it was. It was as good as it could get 10 years ago.
That's right.
SPAN didn't exist in this way.
Exactly.
And things like as SPAN now are available to us, and everybody wins.
Exactly. So now we can go back to our program here. I'm going to comment this back out. I'm going to uncomment our benchmark switcher. We'll run this again. Do you remember what the numbers were? I think they were 15 nanoseconds and 96 bytes. Does that sound about right? But now that we've made these changes, we'll run it again. And what we should see as the numbers start spewing out is that our changes have measurably improved both throughput and an allocation. And in fact, when this finishes in just 3, 2, 1, now, you can see that we're down from 15 nanoseconds to 8 nanoseconds and from 96 bytes to...
Effectively cutting both allocation and time in half.
Exactly. And this is a really interesting point, because when people think of performance optimization for .NET, people think about, oh, I'm optimizing throughput. Why aren't you starting with the CPU usage profile and focusing on that? But in my experience, focusing on allocations first accrues to both. And there's a variety of reasons for that, why I start with the allocation. The first is allocation has some cost, right? Now, for small objects, it's a small cost. Often the GC is able to just sort of bump a pointer, but it still needs to zero out the memory if it hasn't been zeroed out. And for a larger object, like an array, it might have to zero out a lot of space. There's also, for whatever I'm constructing, there's a constructor to invoke. So there's arbitrary code that's sort of a side effect of allocating. I'm also calling a constructor. That can take a lot of time, depending on what it is. The other sort of two interesting reasons, though, are one is anywhere you're allocating, there's often interesting things happening. And so when you start focusing on the allocation first, you often end up seeing things around what you're looking at that you can also focus on as well, and that ends up taking out code. And the fourth, which is the least technical, but I think the most interesting, is, at least for me, performance optimization is addictive. I mean, it is super addictive. You get a little taste of it and you want more. And looking at these allocations, like you saw, we were able to, just like that, pick off a few. Yeah. And now I want more.
But do you need more? I mean, 8 billionths of a second?
Well, maybe not for this function, but there's tons of other files that we can go look at.
I can quit anytime I want, man.
Exactly. So let's do that. Let's look at another one. So there's a lot of other functionality in Humanizer. Let's look at another one. There's a function called a type called to with an API called transform. So you can give it some text, and then you can say, I want to transform this in a certain way. So let's say, hello, build, how are you? And the transform that I want to produce is to use sentence casing, for example. It's got lots of different kinds of casing. Sentence casing basically is make sure the phrase that you're giving it starts with an uppercase character, okay? There's title casing, and there's lower casing and upper casing, and so on. So let's run this through benchmark.net.
And is it necessary to do things 10,000 times? Like, and how many people are calling that 10,000 times? Most of us aren't calling that more than once or twice.
Well, you're probably only calling it in you're rendering your web page maybe a few times, a handful of times. But how many times is your web page being hit? Right? It adds up.
And there's your 10,000.
And there's your 10,000. Probably way more than that. So this particular operation took 28 nanoseconds, but this is a pretty large number. Right?
For a sentence.
For a sentence, especially for a sentence that was already sentence case, right? It already begins with an uppercase letter. That's interesting, right?
Oh, yeah. I mean, you could just go, nope, don't even need to be here.
Right, exactly. You just bail immediately. So let's run another profile of this just to see exactly what's going on. We can kind of guess, but we want to actually see. So let's go to Performance Profiler. We're on the exact same thing we just did. quickly finishes. 10,000 allocations doesn't take very long. We go to our allocation view, allocations, we zoom in.
Oh, wow.
Yeah, right?
What is going on?
So there's a few interesting things here. So now we have 4 objects being allocated when, again, I sort of expected there to be 1 or none, right? We have 2 strings. We have an array being created for some reason, and we have an enumerator object. This SZ generic array enumerator is the type you get back when you call get enumerator on an array, on a T, T array. So let's drill into these. Let's focus first on the strings. So
Is that almost 2 megs of strings?
yeah, for these 10,000.
Yeah.
So I'm going to go to double-click on this, see where they're coming from, zoom in over here, and we can see they're coming from 2 cases. So one of them is coming from this 2-sentence case transform, and the other one is coming from string.concat. So let's focus on this first one. I'm just going to right-click on it and go to source. Oh, that's not the one I wanted to go to source on. I wanted to go to source on one line below that where string concat was actually
Just to let people know what you just did there,
Yeah.
because you said go to source file, you actually dropped into the source file for the .NET
for my
framework.
code. Yeah,
For
string
code you wrote at work.
Yeah, exactly.
Right. And then that moment right there, that symbol loading, you've got symbol source and every source server all set up here.
It was just going straight to the code for the .NET runtime.
Nice.
Because I asked it to. So, the thing we observed is I was passing in a string that was already sentence case, and yet for a string that's greater than or equal to 1 character, it is concatenating a brand new string with another substring, even though it was already what it needed to be. So let's just special case this. This is another form of optimization, right? You find something that's super common, and you special case it. So I can say, if char is upper, input sub 0,
Bail.
bail. Just return the original string, right? We'll deal with the rest of that later. So that takes care of one of them. But if I run this, the profiler again now, well, actually, I'm not going to run it again. We'll just address everything in one go. Let's go to this other interesting case over here. I'm calling this transform function. So let's see if I go to the source for that. Source file has changed. Oh, because I just
changed it.
Yeah. Let's back up one then. We'll go to.
Well, 2-sentence case is a little more sophisticated than just making the first character, have a capital letter, right? I mean, it's looking at.
Well, in this particular case, no, it's not.
Okay, just curious.
Yeah. In this particular case, it was just if we can go to the implementation of it, it was just uppercasing the first letter and concatenating it with the substring. For the
okay.
So let me go to what this transform function is.
Now, I would think with a span, you could just go and flick that first one to uppercase and get out.
You would think so.
You would think.
Yeah, let's see where we end up here. So this is interesting. A couple things that from a performance-minded person jumps out at me here. First, params, right? So with params, when I call this, I can call this as I did out here with just passing in whatever transforms I wanted to apply. And at the call site, though, it's, if I look at what function this is calling, it's calling this params array. So it has to allocate an array. That's where that array.
Right, and then index into it multiple times.
Exactly. But that indexing itself, I'm not indexing directly. I've got this call to links aggregate method, which needs to enumerate all of the transformers that are here. That's where that enumerates.
Yeah, and in this case, there's just one.
In this case, there's just one, right? So there's a variety of ways that I can choose to fix this. The way that I'm going to choose to address it, I'm going to add a new overload. And this is a good case where, I don't own this open source project. So if I wanted to contribute these fixes, which I plan to do, when in the comfort of my hotel room later, I would need to confer with the maintainers of the repo to decide, are you okay with me doing these kinds of changes? I think that's cool, but let's talk about it. Now, instead of doing params array, there's this really cool feature in C# 13, which I'm using here. That's the one more change I made. I told it to use Lang version preview. I can actually change this from an array to a read-only span of iString transformer.
And to be clear, C# 13 not out yet.
Not out yet, but you can grab the bits today and play with it.
You can play with it.
And
okay.
That's exactly what I'm doing. And if I go back to the call site, we can see now, instead of calling the params array version, it's calling the param span version. And this is incredibly efficient from the call site. What this is going to do, it's going to store this into a local variable, and it's going to end up being, like I said, new read-only span in that variable. So it's just creating a span to refer to that exact memory location and passing that in, 0 allocation. Now, I go back to my code over here, though, and I have a squiggle, right? Because I'm trying to use link. So I do need to change this code to not use link.
So it needs to aggregate over that read-only span in a
Exactly.
different way.
But that is a super cheap thing to do and a super easy thing to write. So with arguably less complication than using that aggregate overload where you have to know what the delegate is doing and how it's being called, I can just do what Copilot told me to do, which is for each transformer and transformers, pass in the input I currently have, store it back, and then just return that.
And the squiggle is gone.
And the squiggle is gone.
Nice.
Right.
Now, it is worth noting, though, that one of the things that Humanizer is really well known for that you mentioned at the very beginning is it builds for every version of .NET backwards and forwards, up and down, sideways. And you've gone and customized this to, for the purposes of our talk, just target 8, and you've turned on Lang Preview. If you were going to work with the team to add this improvement, you'd have to ask yourself, well, which versions of .NET support the thing that I want?
And how would I want to write it differently if I was targeting a preview?
And then do you if-def your way around that?
In some cases, this one wouldn't actually require it. This one will, well, it would require it for, this one wouldn't require it. This one would just work. But yes, in other cases that we'll see, we would want if-defs.
So you can use the new version of .NET and target
The new version of C# and
new
target
version of
older,
C#
older
rather,
versions
and the
of,
older version of .NET.
Yep.
Good. So you get all the benefits of the syntactic sugar of the language and all the goodness of the new C# 13, and you can still maintain compatibility. Lovely.
So let's run our benchmark again. Now we're still using the sentence that is already sentence cased, but in that case, we should see a dramatically different answer now. Before it was, I don't know, it was about 30 nanoseconds and about 216 bytes of allocation. And you can already see in the numbers that are coming back now that when this is going to be about 3 or 4 nanoseconds. Oop. There we go. 3 nanoseconds and 0 allocation. So for that case where it was already sentence case, thank you, yeah. But wait, there's more.
Remember, the rule of scale is if you can do nothing, you can do it infinitely.
Yeah. A lot of performance optimization is finding things that you don't need to do and not doing it anymore.
Yeah.
But we can still fix the case where we were doing something, and we can do it exactly as we saw previously. If I go to definition.
Dr. Tobe, it hurts when I do that. Don't do that.
Stop doing that. Yeah. So, again, this is the exact same case we saw before, and we can apply the exact same solution. So I can say string.concat, I can do comma, come over here. I'm going to make this as span instead of substring, and I'm not making this any more complicated. Now, you notice I'm getting a squiggle, and that's because this toUpper is actually producing a char, not a string, and there's no string concat overload that takes. What was happening previously was the char was, there's an optimization that came into the C# compiler like 2 months ago or something, where the compiler was actually recognizing that it could create a span directly around that character and use it directly.
So you got a char and a string here.
Yeah, so what I'm going to do here is I'm just going to do it myself, do that optimization myself, and hopefully in the future the compiler will be able to do this as well.
Okay.
And then I'm just going to pass in a span myself. So I'll say new read-only span of char, passing in that C.
And for the people who are not var fans, if you hover over var, what does the compiler think that var is right there?
Oops, that's not what I want to do.
No, what are you doing?
It thinks it is a char.
Well, it thinks it's char because yeah, there you go. So it is, it is identifying that as a char.
Yeah, exactly.
Just checking.
Yep.
Cool.
And so this will also then handle the case, which we don't need to run because we already saw it doing amazing stuff, but we've now eliminated all the allocations except for the one that this was returning.
Fan-freaking-tastic.
Right? And now, so we're 20 minutes in and we've already made a whole bunch of things better.
And we're also giving a framework for people to look at their string-heavy applications, whether they be ones that use Humanizer or ones in the similar space. How do you decide when to just stop? Because you said it's addictive.
Yep.
You're making huge improvements here.
Yep.
But really, the profiler should be used to look at the hot path of your entire application.
Exactly. Now, I'm cheating here a little bit because normally you don't just do what I'm doing, which is pick things to make faster without any context, right? You're using some application that you're profiling or some user scenario.
You have a reason.
You have a reason. And then you're profiling that and fixing the things within there. I don't have that here, so I'm making do without it. Where do you stop? Well, what are your scenarios? What's good enough for your scenarios? If a performance optimization doesn't make the code any worse and doesn't make any scenario worse, then sure, if you can prove that it's better and it's a pure goodness. In general, though, the optimizations where they're only goodness, they're pure wins, are relatively rare. A lot of optimizations involve trade-offs where, for example, you make something way faster in exchange for making something else a little slower. And then you need to evaluate, the hope is that the thing that got a little slower is very rare, and the thing that got faster is very common, or it got so much faster that it's going to counteract any downsides. But we make these trade-offs all the time, and we evaluate them all the time.
So you're not only a plumber, you and the team are designing pipes, new kinds of pipes, while other people in the audience might be actually making houses that use your pipes. Are they expected to know about this level? Like how much driving stick shift are you doing here? And would you encourage people to spend time learning this? Will that make their text boxes over data, business line of business apps better?
I expect them to benchmark and profile their application.
Agreed.
And then everything from all levels of the stack pop out.
Yep.
And if they can address their scenarios with stuff at their own level, that's where they should start.
Yes.
If they can't, they should come talk to us. Now, hopefully we fixed the stuff at the lower level. But if we haven't, come play with us in .NET Runtime, come play with us in .NET ASP.NET Core, and let's fix it together.
Love
but
it.
the interesting point is, the interesting thing is most applications in the .NET ecosystem don't just depend on .NET Runtime, .NET ASP Core, .NET Core, and nothing else. They depend on a plethora of libraries from across NuGet. Here we have an example of an amazing library that's been around for a long time, is used by tons of people, 50 million downloads. And there's still opportunities for improvement that can then accrue to those applications. So we can all kind of come together, kumbaya moment, and fix all these things across the ecosystem.
Fantastic.
Yeah. Let's take a look at another. Let's do a more complicated one. These are, we're kind of just playing with characters and stuff.
Are you plugged in?
I was supposed to be plugged in.
Is that your plug-in thingy there?
Yeah.
This one goes over to here.
This wasn't plugged in.
Oh,
There we go.
Plug that in.
Great.
Now we got to do the whole thing again.
Oh,
It's
man.
faster. Okay, cool.
All right.
What you got?
So let's do that. I'm going to close some of my windows here just to keep this nice and
Okay,
tight.
we're going to declare tab bankruptcy.
Yep. Tab bankruptcy. I like that. It's kind of like, what was it? Your desktop bankruptcy? You just move everything.
Yeah, just move everything
desktop.
into a folder called desktop.
Yeah.
I moved it back when I got back to the hotel.
That's awesome. All right, so I was browsing around seeing what kind of functionality, and one of the things that I saw was cool that it had was it's got this functionality for Roman numerals.
I've seen this. Claire showed me this a while back. This is one of the coolest things that you didn't know you needed in your life, and then
you play with it. So like you can say, from Roman, and I'm going to do this in my head.
When I was a kid, when I would watch the credits on old movies, and they would go back, and it would be like MCM, VVVI, and I'd be like, 1957.
Exactly.
I just want to, but the challenge is to get it before it scrolls off.
So I can give it 2024. That's the current year, right?
Yeah.
And so let's
find out.
This should give me back 2024. So let's profile this one. Double tests. Now, any kind of parsing thing like this should be basically free, right? There's no reason this needs to allocate, and the amount of work this needs to do should
Parsing should be free, bold statement.
pretty close to it, right? We're looking at 6 characters and figuring out a number that it translates to, but it allocated 216 bytes and took 240 nanoseconds.
Yeah, chunk of time.
That's not free.
Okay.
Especially if I'm doing this a lot. Now, I'm not sure if parsing Roman numerals is going to show up on your ASP.NET Hot Path, but let's pretend that it does. You're building, Roman mythology.
Well, if you're thinking about the Roman Empire basically 5-6 times a day, as one does, then,
or 50 billion times a day, as one does. Yeah.
Yeah.
So let's profile this. Now, because it was taking a lot more time,
Yeah.
I'm actually going to switch this time and use a different profiler, because I'm curious to know why it was taking so much time. So now I'm going to switch over and I'm going to use...
Right, because we were looking at allocations before, saying that allocated a lot of memory. In this case here, it took a chunk of time.
Exactly.
Right.
When you're 16 nanoseconds, probably not worth CPU profiling. 250, I'm curious what that's going to do.
Okay.
So we're going to select CPU usage. And I'm going to come back over here, uncomment this. Now,
I am noticing, by the way, that this is a thing that you're doing enough. It makes me wonder if there's something that can be done to the benchmark to like easily switch back and forth between these two things.
Now, for allocation profiling, I generally want a small enough number that it's not going to overwhelm the system with data, but a large enough number that it's going to escape the sort of the noise.
Okay.
For CPU profiling, I want this to run for a lot longer. So I'm going to, because the way CPU profiling works is it basically takes a sample of every thread once a millisecond.
Right.
So I need it to run for long enough time to collect enough data.
And just quick aside, we've talked about this before. The underscore is the comma for the North Americans, periods for everybody else, but it's the thousands separator that you put there to make you feel comfortable.
To make sure that at a glance I can see what my number is. In reality,
it's ignored.
It's ignored.
Yeah.
So I could put it anywhere I want and it wouldn't affect anything, but I do it so that I can clearly see, oh yeah, this is 100 million.
Okay, so you do 100 million or something.
Yeah. So now we're going to run that profiler. We're going to do CPU profiler. Start that. You can see in the background here, it's starting to, it's showing me that it's, that it's running. I've got 16 logical cores here, so that's about 1/16 of the size. I'm going to let it run for about 15 seconds
You didn't
or so.
parallelize it, so this is just running on one
core, yeah,
one core?
exactly. I'm going to stop that, let it collect all the data that it wanted to collect. It's processing it. And now it's going to give me a report showing what the most interesting things were in this trace.
This is super interesting because we did a whole hour and a half on regex.
We did. And you'll notice that it's telling me, Control 1, there we go. It's telling me, hey, you're spending a significant portion of your time in a regex.
So it's your fault.
It is my fault. But I'll fix it.
Okay.
We're also spending a huge amount of time in dictionary lookups. Right? Basically, all of our time here is being spent in dictionary lookups and in regex processing. That's pretty interesting, right?
That is interesting.
Yeah, so let's figure out why. So I can drill into that. I can click on these things and figure out what's going on. I'm just going to dive right into the code because it's just a simple function. From Roman. Man, laptops are hard. So far, so good. We've got a string, and obviously we're processing a span. So this code has been updated a little bit since span was introduced.
Nice.
Which is pretty cool. I come in here, I'm trimming it, and then there's this is invalid Roman numeral. That's interesting. Let's look at that. And here's our regex. So we're doing an is match.
This is them trying to get out as soon as they can. If it doesn't look like it's a valid Roman numeral, probably if it doesn't have M's and C's and V's and I's, bail.
That's
probably
exactly
has a big regex for that.
And it's a big regex for that. Now, this is a big regex. I'm not going to stand up here and try and optimize this, especially because I don't really, looking at this at a glance, I mean, I know regexes, but
I also know that if you have a regex and it passes all the tests, you should look away. They sense fear.
they do sense fear. Yes.
It works. I don't want to piss it off.
But I'm gonna play nicely with it. We're gonna become friends, and it's gonna tell me about itself. So I've just made the class partial, and I'm gonna take advantage of the regex source generator to learn to help me to do two things. One, it's gonna optimize it a little bit better than this code. It's gonna do it at build time rather than at runtime.
Right.
And it's gonna give me information that I can use to gain some additional insights into this. So I'm gonna say generated regex.
And the difference here is rather than jitting the regex, it's going to actually show you the source. It's going to source generate the regex. Regexes are a little tunneled programming language within your programming language, and it turns into a whole C# application. And you can go and check that out in our Deep.NET series where we dig into that.
Exactly. Now
He's not changing it.
I'm not changing it. I'm just moving some stuff around. Now, there's actually an analyzer fixer that would have done what I just did automatically for me.
Oh, really?
Yeah, there
That's
is.
cool.
But just before we came on stage, I was getting really annoyed with some of the style choices that were made in this code base and the analyzers that were giving me errors when I didn't agree with the style. And so I turned off all analyzers.
All right.
So I've converted this into a source-generated regex, and then I just need to go fix up one call site down here because I made this a method. So I need to go and replace this with a method call. But the interesting thing you saw popping up there and getting in the way of my cursor.
That's amazing, though. Like, that should be called out as being amazing.
Yeah, definitely. So what we see here is when I hover over this, you can see this description of exactly what this
That is a generated description. The generator is already run, and you're looking at docs.
Exactly. So if I go to the definition here, we can see the source generator, in addition to spitting out all the code to implement this regular expression, it also spit out those docs to describe what this is.
Okay, I want to make sure everybody understood what just happened there, right? He had a regex. He then made it not a JITted one, but a compiled one. The source generator made this. All of this was generated passively in the background.
Yeah, live as
you were typing.
As I was typing, exactly. Now, one of the interesting things that, this helps me learn about it, but it also helps certain things pop out about this regular expression. And if I'm just going to double click here and highlight the word capture. You see on the right-hand side, all that yellow?
I see a lot of greedy and a lot of capture.
Yeah. So there is a whole lot of capturing going on. And the interesting thing about regular expressions is, if I go to you can see the regular expression up here, parentheses mean multiple things in regular expressions. It's not just a group that you use to make things convenient. They're capture groups. So there's actually work associated every time you have parentheses in a regular expression, except all I'm calling is match. So in my code here, if I go back and look at all the things that are being done, all the times yellow is popping up here, that's all work associated with doing captures.
Not related to matching.
Not related to matching, because all I'm asking is, did this match, not please tell me what the matches were. So I'm going to go back to my where that regular expression was, and I'm going to add one more option here to regex options, and that's explicit capture. And this is saying that double duty, the parentheses we're serving, have them only be about style and not about capture groups.
Okay.
Right? So let's run this.
Now, Humanizer is known for its tests. When you make changes like this, you're going to want to be running those tests and make sure you didn't break any actual functionality.
I will. And there's a whole bunch of tests over here that if I was a good citizen and had more than 9 minutes and 40 remaining,
Touche.
I would run.
I just want to call out our friends who work on Humanizer. 13,000 plus tests.
Yes, huge.
Fantastic.
Awesome. So let's run this again. Now remember, it was about 250 milliseconds, I believe. 250 nanoseconds before. We made one change. We added regex options dot explicit capture.
Did it matter that you changed it to a compiled regex using a source generator? The result is the same.
The result is the same. The regex source generator and the regex compiler are pretty close in the source to the output. The regex source generator is a little bit better, but in this particular case, it's not going to matter a whole lot. So just by adding that one option, we've now shaved off about 1/5 of the cost of this, thanks to that insight that the profiler told me, hey, go check this out. Now, I could probably optimize the regex further, but I have bigger fish to fry. Because if we looked at the amount of time that was being spent from the profiler, it said a huge amount of time was being spent in dictionary lookups.
It was.
Why is that? Well, if we go down here to the main processing loop, we see we have a dictionary here. And we also see some other unfortunate things, like we're calling toString on every character that's being passed in here. So we've got an individual character. We're calling toString in order to do a dictionary lookup.
So it's pulling them out, and what, it's getting out chars, and then
converting it to string. Now, if you look at the dictionary, it's pretty clear why that choice was made, because there are things showing up in the dictionary here that's more than just a single character, and it's doing ordinal ignore case. So it's trying to handle lowercase as well as uppercase. Why is it handling things that are longer? Because we were just doing individual character lookups. Well, this, when I went and explored, this is used in a couple places, not only in this function, but also in the toRoman function. It's enumerating over this dictionary in order to produce the right output.
And if it was a single character, it could be a faster lookup. It could be lowered to an array lookup, an array index rather.
Right.
But these are sometimes one, sometimes two.
Right. So what we realize is we actually have two different purposes that have been joined together into the same dictionary. We have a purpose that's enumeration, which would actually be better served by an array.
Yeah.
And we have a purpose that's just for individual characters, which would be much better served by not having to toString each individual. So we're going to go and we're going to fix that. We're going to copy this whole thing, and we're going to create another one, and we're going to create things that are destined for their own individual purpose. Okay?
Single responsibility principle.
Single responsibility. So instead of a dictionary, I'm going to have a key value pair from string to integer, and we'll call this Roman enumerable sequence.
Isn't a dictionary already a key value pair, Stephen Toe?
It is, but it is much faster to enumerate an array than to enumerate a dictionary. Okay? So, and I'm now just going to go and I'm going to quickly just delete a whole bunch of things here. Hopefully I don't delete, this is where tests would come into play, because it's probably pretty easy for me to accidentally delete one of these lines that
What could go wrong?
Right, exactly. We can use collection expressions. And then I'm going to take advantage of one of my favorite features that saves me so much time in Visual Studio, and that is if I do Alt drag, I can now type on, if I don't hit a key while I'm trying to do that, I can just type the same thing on each line, so key value pair dot create, right? And then I'll do the same thing on the other side.
Everyone clapping's never used VI or Emacs at any point in their lives. But seriously though, knowing that kind of stuff, if you want to make people at work feel bad about themselves, do it in front of someone, just do it casually, just throw it in a meeting.
So then we're just going to use this array down here for the to case. And so this is going to,
cool.
thank you. This is going to make this case better. While I'm here, I noticed I said we also see things as we're optimizing these allocations.
Yeah.
With this loop, when you look at this loop, and this loop is basically going from the highest value things to the lowest value things. And it's basically saying, use as many of the higher value things as I can, and then move on to the next.
Order matters.
Right. So it's saying, while the input divided by pair.value is greater than 0. So it's looping over, like it's doing all the m's, and then it's doing all the cm's, and so on. there's a faster way to do it than dividing. When it comes to numerical operations, plus, minus, times, divide, divide is the most expensive. For some reason, it was written this way when it could have just been written as long as the value is, the input is greater than what's left. So we can just save a few cycles for there as well. Not a big deal, but these things show up around these allocations. Now we have this dictionary to deal with. So we already said we were only doing lookups with an individual character, right? So I'm just going to go and I'm going to get rid of all the double ones. Oops. Again, that's where tests are valuable. I'm doing something wrong.
And it's your laptop, so you can't complain about keyboard
I know.
fail.
Well, I can complain.
Well, you
about
and I are desktop people, so we should have brought our mechanical keyboards.
There you go. All right, and I'm just going to get rid of all these extra braces as well.
Okay.
I keep hitting the
I'm
trackpad.
just impressed that things are happening.
All right, so we're down to the data that we care about.
Okay.
Now we could do this as a dictionary, and I'm going to come back in here and I'll do my little trick of replacing these things. So I'll do that. Right? You can go from character to value. But C# has a built-in construct that does this, and I don't even need a dictionary, right? It has a switch statement, which has been around for, well, since C#.
Yeah, but if you do a switch, then you do a go twos, and then it's a slippery slope, and no? Stephen loves his go-to because nothing is, you can be a go-to hater, but it's faster than heck.
So let's just have a character come in here. And I'll tell you what, we won't
Saying
use...
switch statements are a gateway drug.
Okay, then we won't use switch, we'll use switch expressions. How's that?
Okay,
Great.
impressive.
Okay. So then we'll just say C switch, and for each of these characters, okay, yeah, Copilot will do what you're, there we go. We'll do what Copilot's suggesting. Great.
Oh,
Perfect.
look at that.
And then we need to change this to be the integer value. Okay. Now we do have one difference in, read only, yeah, right. It's no longer a dictionary. There is one difference in behavior here, right? We had that string ordinal ignore case thing, which we don't have here. So there are a variety of ways we could tackle that. I could come in here and I could say or M. I could come in,
Well, and this is challenging because this is important. Now, as soon as you can do MDC, but when you get down to the I, you've got the Turkish I problem.
You have the Turkish I problem.
Which is a whole thing.
Yeah. But for this purposes, not going to worry about
Turks have 4 eyes, by the way. If you're Turkish, you know this. And if you've done any kind of internet, Humanizer is very well known for its support for multiple languages. If you have a lowercase I with a dot over it and you upper it, in English, in most languages, it becomes an uppercase I. In Turkish, it becomes an uppercase I with a dot on it.
Yeah, 0x130 or 0x131, whatever the values are.
So I just have a whole speech there, and you got to make me look bad by calling out the actual Unicode code point.
Well, I might be wrong.
Because you actually know, yes, there's actually a Unicode code.
Well, I'll look it up after. I'm not going to worry about that for now, though, because I want to call out the techniques.
Yes,
but
sir.
let's assume we're only dealing with ASCII. So the ASCII table, like the first 128 characters of UTF-8,
Okay.
that came about in the 1960s and 1970s via a variety of standards. But the people that designed it were brilliant. And they had this really cool thing they put in place, which is that the uppercase Latin English characters differ from the lowercase ones by a single bit that you turn on and off. And so there's this really fun trick you can play. In fact, I bet we can even ask Copilot to say, the ASCII value of A is 65. Great, yep, that's right. It's already telling me for lowercase a. Okay.
Yeah.
Okay, the difference is...
Yeah. Okay, dude, back off.
You get the idea. But there's a bit trick we can play, which is if I have a lowercase letter, and I and
stick the landing in 90 seconds.
Yeah, and I and it with this, it will become the uppercase version. And if it's the uppercase version, it'll stay the uppercase.
And that might not work for a really, really broad series of letters, but the only ones we care about are Roman numeral letters. It's a very constrained thing, so you can probably get away with this.
Exactly. And it's already been verified because of that regex that we saw earlier. So I'm just going to come in here, delete that. Don't delete that. Am I going to compile? We'll try. We'll come back over here. We'll run this again. It's the Mission Impossible scene?
No, it's not. It's a non-related, uncoupled. I'm just talking, just random notes.
Sure you are.
Okay, you have 42 seconds.
So we were at 250 nanoseconds with 216, I think, bytes of allocation, and we're down to 5 times as fast.
And 0 allocations.
And 30 seconds left.
Very nicely done, sir.
Thank you.
Woohoo! Fantastic. How fun is that? This was a highly technical talk.
Why, thank you.
If you enjoyed this highly technical talk, I would encourage you to rate it and share it with your friends. Be sure to subscribe to the .NET YouTube and take a look at our .NET Deep.NET series, and have a great time tomorrow. We've got much more for you here at Microsoft Build.
Thank you. That was fun.
couple buckets, right? We tend to see a lot of Gen AI use cases, at least right now, as we're kind of getting our feet wet with this.
Yes.
A lot of use cases around making sense out of text information or documents.
Yes.
We also tend to see a lot of use cases around increasing efficiencies, right? Or doing something that we were doing before, but doing it a lot faster.
Okay.
And then we also see a lot of use cases around searching what data you have in any form and getting that returned to you very quickly, right? And so, specifically in the retail sector, we're seeing a lot of sentiment analysis, right? So that sort of falls into saying, hey, making sense out of some text data or some documents that you have, understanding what your customers are thinking about you or your products. And then in the efficiency gain is personalized recommendations, right? Nothing new, right? We've been doing that for a while in retail, but there are lots of ways of doing it more intelligent, doing it quicker, doing it more efficiently with Gen AI capabilities.
Okay, so I, of course, am extremely biased toward retail cases. I run a fashion company. So this is very cool. Like looking at consumer sentiment, this is a thing AI can actually do, reason over all and all of that data and make some sense of it.
Right.
So I'm a believer that generative AI generates, and we should do cases that are good for Gen AI rather than throw every single use case on the planet as a Gen AI thing. Because not everything is a Gen AI. Some can be predictive AI from, back in the day.
Right. Yeah. Not every problem is a Gen AI problem.
Right.
Also, what we're finding too is that problems that maybe weren't a Gen AI problem now can be solved a lot more quickly and a lot more efficiently with Gen AI.
Right.
And it's often a good place to start there with something that we've already kind of been solving, but we can do it more quickly and better.
That's right. So where does Azure fit in? Because I know that is a thing that you all integrate with.
Yes. So I guess more specifically, looking at what we have at Snowflake. So Snowflake has its own generative AI platform called Cortex, right? That's the kind of the big word here.
Cortex.
So within Snowflake, it's already generally available.
Okay.
We have all these experiences that allow our customers to use AI or generative AI in seconds, right? So you can use these pre-built functions with LLMs that we have inside of Snowflake. We have all these experiences around search, around document AI. We have our own Copilot.
You have your own Copilot?
Yes.
Go on.
We also have something called Streamlit, for those who aren't familiar. It's this really cool, basically a Python package that we have inside of Snowflake that allows our customers to very quickly develop applications that can be built on top of all of their generative AI functionality. Also within Snowflake is we have the functionality to bring in external LLMs or bring in your own LLM applications, and importantly for this conversation, make external calls to other generative AI platforms like Azure OpenAI and OpenAI.
Right. I love that.
Because the one thing is great is that the Snowflake platform is expanding, right? We have all these generative AI capabilities, but it gets confusing, right? Because Microsoft, I don't know if you heard, has some generative AI capabilities as well.
A few.
Yeah, so it's kind of use case dependent, right? So a lot of different use cases will kind of be used, you'll want to use the different LLM or different generative AI capability depending on the use case. Our product folks are smart enough to realize that, and you have the flexibility to very easily and securely set up these external calls to Azure OpenAI.
Okay, I love that, because what you're doing is leaning into where you all have the specialized information. Right? You have special data, you have special information. So you're able to build AI products that fulfill your specific use cases using things that already exist, like Azure OpenAI. But you also use your own custom models and things where it makes sense, in the use cases where it makes sense.
For sure.
Okay.
Yeah, and we encourage our customers to go ahead and experiment with Cortex and use Cortex and use it in your production workloads. But in addition to having this really great platform, Snowflake also put a stake in the ground of saying, hey, we have built our own generative AI model. We have our own LLM called Arctic, right? And there's kind of three big differentiators that go along with Arctic, right, or come with Arctic. Number one, it's enterprise grade, right? When you look at the benchmarks that we put out, it's right up there with a lot of the other top LLMs for a lot of different LLM use cases. Second, it's a breakthrough in efficiencies. We're using this thing called experts, right, that allows you to very quickly get your response back from a prompt with your context, so you're not, spending too much money, using too many tokens to get your answer back from generative AI. And then lastly, it's truly open. It's part of the Apache project.
Oh, nice.
You don't have to give your mother's maiden name, your email, or a bank account number. You can go ahead and use the models as you like. And also, very importantly, it's available, Arctic is available inside of the Azure Model Catalog right now. So if you're not yet a Snowflake customer, you can use Arctic inside of Snowflake, obviously. But if you're not yet a Snowflake customer, you can use Arctic inside of Azure right now.
I like that. In the Model Catalog, Models as a Service, this is exactly what we should be doing as a tech industry, right? Making models available to people for their specific use cases where they already live, where they are at, rather than trying to make them go switch to something else. So I think people should try that out if you're Azure customer, not yet a Snowflake customer. But if you're a Snowflake customer, obviously use it this way. I hear you have a demo of some sort. Do you?
That's right. Yeah. So let's take a look at the very simple architecture.
Okay.
And I love simple architectures.
I love that.
Of this demo that we have, right? So the idea being is that everything is inside of Azure, right?
Okay.
Reminder to everyone that when you deploy Snowflake, you're going to deploy it to a cloud. Snowflake is going to be right on top of Azure, right? It's going to be using blob storage under the hood. It's going to be using Azure Compute. So what you have here, those first three purple squares are kind of showing standard what you do in Snowflake. You have some data, you do some feature engineering, and you make a dimensional model, or you have some data, whether that's a dimensional model or unstructured right inside of Snowflake. And the key comes in that fourth square, where we have the Streamlit. That's that crown right there. That's the package that we have that allows you to build applications quickly and easily in Snowflake. And then that little mountain there, because Snowflake loves naming everything after.
I see that.
Yeah,
I see the
Arctic,
theme.
right? So that's called Snowpark External Access, right? And Snowpark External Access is a available functionality that allows our customers to very easily and securely connect to external services. So that's like the key linchpin that allows our customers to make the external call to Azure OpenAI.
Okay, I like that. What is it? Say it again. Snowpark
External
Access.
SPEA.
You're naming things like we are now. Yeah, I know. Snowpark External Access.
Why not another acronym?
I
right?
know.
Yeah.
SPEA. Okay, I got you. Okay, go on. Go on.
All right, so let's take a look at what it winds up looking like.
Okay. Oh, I like this. Wardrobe recommender.
So it's a wardrobe recommender.
Okay.
So what we
Everyone
have.
pay attention. Pay attention. Okay, do it.
So what we have right here is the actual application, right?
Okay.
What a user would have to do is enter some sort of prompt.
Yes.
We defaulted with this prompt of reviewing the image and selecting an image of a person and what they're wearing. And what we're going to be doing is we're going to be accessing this image that's sitting inside of Snowflake. And then we're also going to grab a table of URLs to other clothing items and then pass that to Azure OpenAI and ask Azure OpenAI for a recommendation, saying, hey, look at this image, look at the way this person's dressed, look at these URLs, and tell us which of these URLs are the best fit for this person.
Okay.
Had I known that you were going to be as great.
Fashion-y?
There we go. Yeah. I probably would have picked some better outfits, but you can see we have this gentleman wearing a white suit.
Yeah.
And the application and Azure OpenAI come back with some pretty good recommendations,
I like
right?
that you went to real things.
Yeah. So we have a blue Poplin Tommy Hilfiger shirt. And yeah, great. A white.
Love it.
Yeah. Chambray suit separate that I think that gentleman would probably wear. And the really cool thing about this is that this is all 41 lines of code, right? So this is 41 lines of code inside of Streamlit. It's all inside of Snowflake. You don't have to manage any infrastructure. And we have a quick start that's on quickstarts.snowflake.com. You can go in there, search OpenAI. We have several quick starts. If you already have a Snowflake account, if you already have an Azure OpenAI service, not exaggerating, you can set this up in probably 30, 40 minutes.
Do you have a GitHub repo for this? Because I'm extremely interested in it.
Yes, and it does link to a GitHub repo.
Oh, okay.
For sure.
Thank you.
Yep.
Thank you. We did not plan that. I thought he was going to say no, and I was going to assign him homework to make one. So that backfired. But that's awesome. I love this because it's a problem for people, not just me, but for people, right? I like this kind of thing for this conference. I'm going to Chicago for Ignite. What should I wear, right? Something like that. I love this. This is like the Netflix recommendation engine, but in 46 lines of code and not with many, many, many more lines of code.
Yep. Yeah.
Isn't that funny how tech can just solve these, like you were saying, things that used to be hard but possible are now way the heck easier.
Yeah, that's right. And so the way that this is set up, so the 41 lines of code here is the application that utilizes the function.
Yeah.
You got to create that function. That's in one other script. So and that's, I think, 30 or 40 lines of code.
Oh, wow.
So you're talking 2 scripts.
Yeah.
That's it. That allows you to develop an application, connect to Azure OpenAI, and provide some recommendations.
I love that. That's a great use case. That is a great use case. So this is your use case around wardrobe recommendations, fabulous. And then as people, retail establishments, there's like 65 steps in the process. I liked one of those earlier ones where it's getting customer feedback on things, right? How are you doing sentiment analysis?
Yep. So we talked about some of the pre-built experiences that are inside of Snowflake.
Yeah.
So we literally have a sentiment function inside of Snowflake.
Oh, you do?
Right.
Has
So
that always been there? Or is that AI?
that's
thing?
relatively new. Yeah, that's part of
okay.
so anything that's using Gen AI and
Yeah.
Snowflake is going to be called part of Cortex, right?
Okay, so the Cortex bucket is all your Gen AI stuff. In it is Arctic, which is your model,
Yep.
and with all of these other things in
Yep.
it. Okay, so Cortex is your Gen AI bucket of stuff. I got you.
Right. So
okay.
part of that
Yeah.
Cortex bucket is a sentiment function.
Okay.
And what you can do is you can call that sentiment function, leveraging whatever LLM you'd like to, and understand what your customer feels about you. Right.
Okay.
So again, what was once maybe a slightly more complicated problem,
Yeah.
detecting sentiment analysis, is now a whole heck of a lot easier with Snowflake Cortex.
So have you found that the accuracy is way up? Because that's always my question. Like, can you do sentiment analysis? Yes, you can. Could do it 10 years ago too.
Right.
But I don't know about the accuracy all the time. What do you think now?
I think the accuracy is getting better and better. It's starting to asymptote, I think, right?
Yeah.
So like there's only so much better we can get with
Yeah.
sentiment analysis. But it's getting a lot easier to do,
Yeah.
right? So in sentiment analysis is one of those, it's a really great way to like just start using generative AI,
Yeah.
right? It's something that a lot of us can understand. It's a lot of
Yes,
us can
it
wrap
makes
our heads
sense.
around.
Yeah.
And we know, and like you can start to kind of like battle test it a little bit out there in the wild. It's like, hey, does this customer really like us? Does this
Yeah.
customer really not like us?
Yeah.
How much do they like us? Does
Yeah.
this really pass the sniff test? And it's a good way for customers to kind of understand that, yes,
Yeah.
it is working.
Well, I think it's a good, what is the word? It's a good test, right? Because some wardrobe recommender, it's hard to test that. It's like, is this a good outfit for me? Yes or no? I don't know. Maybe I have bad taste, or maybe this has bad taste. We can't tell. But sentiment analysis, we know the reviews on this thing are actually quite terrible. Why is it telling me good sentiment?
Yep.
Right?
Yep.
It's the human checkingness, the human in the loop part.
Yep.
Is simpler for a use case like that.
For sure. And I mean, and kind of extend that a little bit more as far as like how to leverage text data or documents inside
Yeah.
of Snowflake.
Yeah.
We have our own ability to do search, right, and use embeddings and create
Yes.
a vector data type right inside of Snowflake.
Yeah.
So yes, so sentiment's a lot easier inside of Snowflake, but also now it's a lot easier to create embeddings inside of Snowflake, to use those embeddings to find data, to
Yeah.
find answers quickly, to find context, right? We
Yes,
talk about
that's right,
RAG a
that's
lot
right,
here, right?
yeah.
So you can use those embeddings inside of Snowflake.
So you
to
can ground
access.
in a lot more things too,
Exactly.
right? And say like, so you could ground in the data of these phrases tend to be good, positive, bad, et cetera. What was the third use case? I forgot. So one was sentiment, second one was retail or recommendation. What was the third one?
So I only showed 2 use cases, but I mentioned 3 buckets. The third bucket I didn't show a use case
Yeah.
for was basically some sort of search functionality, right?
Yeah.
So and we have
Search functionality.
yes,
That's what it
right.
was.
So the
Yeah,
idea is that
that's right.
inside of Snowflake you can have
Yeah.
structured data, you can have semi-structured data, you can have unstructured
Yes.
data, right?
Yes.
We're entering this new world where that's all going to be open and easily
Yes.
open to an
Yes.
entire organization,
Yeah.
right? So somebody who is an analyst in the marketing department, rather than
Yeah.
having to run to a DBA or run to an engineer to ask them to query some data or find the answer, they can find it themselves, right?
Okay,
Just with
self-serve.
some plain text,
Self-serve.
leveraging
I like
a lot of the functionality that we
Yeah.
have built inside of Cortex.
I like that this enables people to be a little more free.
Yeah.
They can do stuff for themselves more. Autonomy. I love autonomy. We love autonomy.
Yes,
right?
and the engineers are going to
Yeah.
love not getting bothered by the marketing person
Exactly.
saying, hey, can you drop what you're doing
Yes.
and spend 45 minutes trying to
Yes.
figure out this query for
Dear
me?
marketing people, you're welcome. Listen to the man. Okay, listen.
And finance
All right.
people.
Well, finance people, we usually need money and they say, no, go away. Okay, so Matt, it has been a joy talking to you.
Yeah.
Thank you so much. Where can people find you? What homework do you have, et cetera, et cetera?
Yeah, so I think first things first, if you're here at Build,
Yes.
go ahead and head over to the Partner Expo. We have
Right
a
there.
booth right over there. There's plenty of lovely Snowflake people there who are going to want to talk to you about all that we have inside of Cortex and some of
Yeah.
the fun stuff that
Ask
we're
for a
doing.
demo.
Yes, yeah, and some of the fun stuff we're doing with Iceberg and Fabric too, which is really cool.
I love it.
Also, check out quickstarts.snowflake.com. Search OpenAI,
Quickstarts.snowflake.com.
search Azure, search
Yeah.
Microsoft. There's plenty of quick starts
Yeah.
out there to show our joint customers how to use Snowflake with Microsoft.
Yep.
And lastly, talk to your Snowflake account team. Ask them for some help. Ask them for help showing how to use Snowflake with Microsoft and Azure.
But definitely do the quick start thing because you can do that right now.
Yeah.
All right, everyone. Thank you so much for being here, Matt. This
Thank
has
you.
been a joyful conversation. Congratulations to you. Congratulations to you, Stella.
Yeah.
Have a wonderful build.
Thanks a lot.
Awesome. Thanks, Matt. Thanks, Donna. And thanks to all of our feature partners like Snowflake. We're going to have more exclusive interviews. Easy there, Joey. Tripping over my tongue with our feature partners as we are coming up. And This is really cool. So GitHub's coming up very, very shortly. And I was just kind of sitting over there, and Martin and Christina start talking, and then my head explodes. So you need to stick around to see more of GitHub as we keep coming up.
Absolutely. And we're going to get into the Visual Studio Code Toolkit. I don't want to give away any details. I want you hanging on the edge of your seat.
No, spill tea. Spill tea. Let's talk. Let's talk. Let's
Okay.
talk.
All right. VS Code is one of my favorite editors. It is extensible. You can get it on the web. You can use it. It is what powers code spaces. It's also in your dev containers and in your dev box. And it's created by really cool people.
But wait. You're a Pythonista.
I am. And I do my pythons and my snakes in my VS Code.
I had no idea.
Yeah. And we have all sorts of extensions. Download the Python extension for VS Code, and that gets you all started. You also have this walkthrough that will show you all of the cool features, the debugger, the testing suite, which we're always improving. And okay, not to toot my own horn, but I do monthly release videos for VS Code and Python. So check that out on the VS Code YouTube.
Oh,
see my face.
self-plug. That's awesome. That's amazing. And if you've never experienced it, never looked at it before, you can jump on over to Microsoft Learn.
Absolutely.
Go through a couple of those learning modules and learn a little bit about it.
You're so good at this.
Or if you're an expert, we've got more conversations with some experts, our most valuable professionals.
Absolutely.
Yeah, it's coming.
All righty. Welcome, everybody, to All Things Azure and Azure OpenAI for game development. PC Mag said this is one of the only gaming sessions at Build, so we felt a little pressure to make it fun being the only gaming session. So we thought about like a choose your own adventure game show hosting type thing, but instead we opted for 64 slides. You're gonna get 64, no, we got demos, we got slides. We're really excited to be talking about our end-to-end vision for gaming at Azure. My name is John Kefaloukis. I'm a strategic partnerships director leading our relationships with our largest gaming customers, AAAs in the United States. Working with Utapa and Dan and a huge team at home, big shout to the entire team to build out our gaming at Azure vision and strategy for Azure and Azure OpenAI for game development. So really excited to talk through our top use cases today over the next 45 minutes. This is probably like 3 or 4 hours worth of content. We got one session for gaming, so we're gonna cram a lot within a short period of time. We're really excited to talk through it. Thank you so much everyone for joining. All right, so here's our agenda. Here's what we're gonna be talking through today. We're gonna walk through our end-to-end vision, our gaming at Azure vision for end-to-end game development in Azure. And then we're gonna talk through really our top 4 use cases: game development in build farms, basically Studio in the cloud, game server and game services hosting in Azure and Azure Kubernetes, Azure OpenAI Service and Azure AI Studio, and then we'll wrap up with build, player, and game live ops and data analytics with Microsoft Fabric. If you guys have been here all week, you've heard about a lot of the Microsoft services that we're gonna talk about today, but we're really wrapping those all around in game development scenarios and really excited to dig in. Appreciate y'all coming in and showing up, and for everyone that's watching online. Starting with our highest level, you've seen this slide a million times this week, I'm sure, but we're driven by our North Star in our Gaming at Azure team, which is to empower every person, every organization on the planet to achieve more. From our lens, it's empowering every game developer around the planet to achieve more. And this is important to us, right? It's helping to get rid of the crunch culture that exists in game development. For anyone that works in game development, you know how difficult crunch is, how hard it is to ship a game. And we really do feel that with this kind of end-to-end vision, we are empowering people. We are, restoring work-life balance. And on the right side, you'll see something that I think is an important kind of diagram, right? It lays out the fact that Microsoft, compared to any tech company in the world, probably has the largest wingspan of any technology company. You heard Satya say it in his keynote, but from infrastructure to data services, Sprinkle AI services, to, of course, security, robust security, modern work and business applications to help you collaborate and get things done. There is this vision where you could do and achieve end-to-end game development and simplify what is already a heavily complex scenario. Game development is hard, we all know that, and get game developers back to doing what they want to do, which is building great games, building great features, and getting the technology, the infrastructure, the IT engineering out of the way. That's what we're going to talk about today. So at its highest level, our kind of ethos for our Gaming at Azure vision and strategy is really marked by the fact that we're very fortunate. We have a massive Xbox organization of over 40 studios now with Activision Blizzard King. And the majority of them, almost all of them, are using Azure for all things game development, from builds to services and servers and live ops and data and analytics. Azure truly is battle tested by games like Minecraft and Gears of War and Halo and Forza, and of course our third-party customers as well that are using Azure that we support on a day-to-day basis. So ultimately you have best-in-class infrastructure with Azure, first in global availability, leader in cloud and AI developer services with Azure, but all of that is battle tested courtesy of Xbox and our xCloud and Xbox Vision. And we'll talk a little bit about Xbox services today. Mostly we're gonna be talking about Azure natively and Azure native services, because this is Microsoft Build. But we did want to, I think we'd be remiss to not cover Azure PlayFab. So for those, actually quick show of hands in the room, how many people have heard of PlayFab here? Raise your hand if you've heard of PlayFab. All right, I see like 30%. Okay, awesome. So Azure PlayFab was a company we acquired about 5, 6, 7 years ago. PlayFab offers basically an end-to-end suite of managed services for game development and for games, from live ops to multiplayer servers and services to monetization, leaderboards, et cetera, et cetera. So essentially, if you're a brand new game studio, rather than having to build all these things yourself, which takes time and effort and investment, you could use PlayFab as a managed service. And most of these services are running in Azure, and there's obviously a close partnership between our Azure PlayFab organization, which is out of Xbox, and of course our Azure organization under Scott Guthrie. And all of our Xbox game studios, at least the ones you think of, the historic ones, are using Azure PlayFab as well. So I wanted to make sure to cover what Azure PlayFab is, some remarkable services here, not just for games, but media and entertainment as well. A lot of media and entertainment organizations, sports leagues are now looking at PlayFab for gamification, modernization, and live ops and telemetry and things like that. Some of the PlayFab innovation, this is an outdated slide as of 2023, but in 2024, we've announced quite a bit. Shout out to CJ Williams, David Syed and team, but really a lot of deeper integration into the Microsoft Cloud and AI ecosystem, particularly with Microsoft Fabric and some of their live ops tooling, Azure Synapse. So again, really good extensibility and a really good story for Azure PlayFab and how it extends into Azure. And I think you're going to see that continue to develop as it extends into Azure AI and Azure OpenAI. Some really exciting things happening with Haiyan Zhang's team and the rest of the PlayFab team. But jumping to the meat of it. So this slide is kind of the slide we're going to refer back to constantly throughout this presentation. This is a one-slide diagram of our gaming at Azure vision. From left to right, essentially, shift left as you're just getting started building a game. You have an empty Perforce repo or GitHub repo, and you're basically starting to build out your CI/CD, your pipeline, your build farms. What does that look like? You can do that natively in Azure. We have a massive partnership with Perforce. And especially for kind of indie or smaller, just getting started game studios, you can basically run Perforce in Azure, or you can run Perforce as IaaS in Azure. Again, far, far left, artifacts, storage, build farms, everything you see in the kind of first box, game development and builds, you can do in Azure. One thing I want to point out too, Cloud Dev Kits. This is a commonly requested item, and excited to share that this is being explored as well, is running Cloud Dev Kits natively in Azure as well. From our Xbox organization. So then you start to move right, and as you think of developing features in game, trying to get more efficient, automation with your game development, you can start to sprinkle in Azure OpenAI Service, Azure AI Services, cognitive speech and cognitive services for character content dialogue. There's some really rich functionality there to help you build your game, and Azure ML, so essentially AI-infused tools. And then all the way kind of on the right for the player experience, you have game servers, game services, dedicated game servers you can run natively in Azure VMs or Azure Kubernetes or through Azure PlayFab as a managed service for game server hosting. And when you do all of that in one cloud, again, left to right, the most powerful thing is the analytics. The benefit you get from a telemetry analytics pipeline perspective now with Microsoft Fabric and machine learning and Power BI Copilot is rich, from build telemetry, how your build's doing, performing with testing scenarios, to player telemetry, so you can make real-time changes, you can listen to your community. When you kind of run this end-to-end, left-to-right vision for game development in one cloud and in Azure, it's pretty powerful. And a lot of our gaming customers are somewhere on this journey. Some are a little bit further along than others, and it's been a lot of fun working with the AAA game developers around the country to help enable essentially what is this kind of end-to-end vision. So we're going to jump into use cases for all four of those boxes, and we'll refer back to that one singular slide, which again is our gaming at Azure vision. We'll talk about Studio in the cloud, game dev in the cloud on the far left, game hosting, game services and game servers, game analytics, and AI in gaming. Of course, would be a Microsoft presentation without talking through how AI is transforming the games industry as well. We're excited to talk about some use cases in AI. So with that, really excited to pass it along and introduce who is one of the masterminds or the mastermind behind that Azure Gaming at Azure vision. He's our lead cloud solutions architect for the gaming vertical, Utapa. Can we get a round of applause for Utapa, please? Make some noise. Thank you.
Thanks, John. Hey, everybody. I'm a lead solutions architect. As John said, we cover some of the, one of the largest gaming customers in North America and Europe. So all these are probably from the learnings, and not just from internal studios, but also from external studios. Just a quick question from a show of hands. Can you just point us any game developers in the audience here? Cool.
5 people. Nice. I'm just kidding.
All right. Okay. So yeah, we'll keep this interactive. We'll keep have some demos as well. And thank you so much for spending your Thursday afternoon here, and we really appreciate you being here. So yeah, we'll cover some of these building blocks. Again, I think that's key here, the building blocks, right? So we are using Azure native services for enabling game developers, development, and then all the capabilities that you saw here. So apart from PlayFab, which is a managed service, all the services are here for general use, right? So we are specializing it, making it more enhanced for game development. Why? Because game development is really, really hard, right? Game development, developers are some of the coolest people out there because they create these amazing games. Think about Minecraft, Forza, Gears of War, Halo. All the Microsoft Studio games have some of these components that are being used today. And think about scalability, right? Now you have games played by millions of players across the globe. with sub-millisecond latency. How do we deliver those games? But let's start from the far left, right? How do you develop those games, right? And how can Azure help in terms of remote game development? So, yeah, this is the one, right?
Yep.
Yeah, so talking about remote game development, it is so hard. Why? Generally, game developers have these powerful GPU-enabled workstations on their desk. They have super fast, performant disk and low-level latency connections to other Perforce or other Git, source code systems. Then they also have peripherals attached to them, like think about PAN, right? It's not just for game developers, but also for graphic artists. So how do we enable this on Azure, or for that matter, any cloud, right? So what we did is we worked very, very closely with Azure engineering to build some of these capabilities that are very, very relevant for game developers. So starting with, we are using this service called as Azure Virtual Desktop. Most of you might have heard this. This is probably one of the largest used service post-COVID, because work from home really became a norm, then an exception, right? Azure Virtual Desktop enabled remote development, right, across industries, because we manage the brokering and everything in terms of authentication, authorization, and then you just create those virtual machines really and enable them as virtual desktops, right? The second important aspect of Azure Virtual Desktop is you can run native Windows 11 on Azure, right? With multi-session enabled as well. So now think about it, all the software tools and development kits that are compatible on-prem devices on desk now can be run on Azure as well. So we've used this platform and we enhanced for game development. What are those enhancements? Relative mouse support, right? Which is pretty common and much needed when you, for example, develop or play a game. You can now launch these workstations using GPU drivers that are pre-baked in, right? So we build some accelerators where you have fully baked workstations with gaming tools and softwares with drivers automatically installed so that you can launch these workstations using Azure Virtual Desktop in any part of the world using different regions that we have across the globe, right? Then we also enabled capabilities for optimized 4K streaming and then high fidelity graphics based development and streaming as well. So there are some capabilities that you will see which are part of this GitHub repo. We'll share it as well that enables those capabilities, right? And then game developers often work on multiple projects, right? Azure Virtual Desktop, as you know, can be only assigned to a particular user. So we asked engineering to enable some of these capabilities for assigning multiple projects and desktops for a same developer, right? And then we have a template which includes all these best practices, so you can use that and customize. And then, of course, disk performance, right? So we worked with engineering also to enable enhanced disk performance with Premium SSD V2. Now can go up to like 80,000 IOPS in terms of this performance. And then the last one is a very recent feature, GPU hibernation. Now you can actually hibernate an Azure virtual machine, even GPU virtual machines. What that means is a developer, when he comes in the morning, the virtual machine is ready almost instantaneously the way on-desk workstations are, okay? All right, these are some of the Azure virtual machines that are today enabled for Azure Virtual Desktop and remote game development. We provide, there's a mix of AMD and NVIDIA-based GPU VMs here, and all these are provided with the drivers. So you don't have to work externally to get the drivers. These are available, and these all can be installed part of the extensions. All right, so now you know how to create a game developer workstation. You can also extend that to different phases of game development, right? So on there you see different source code management systems, whether you can bring Perforce. We have a fully managed Perforce marketplace image published by Perforce on Azure that you can use and build your depots on, or you can have your source code on GitHub or Azure DevOps. You can build the build test farms on Azure using scale sets. If you know Spot VMs, which offer up to 90% off the market list rates. And then you can even build your forms using GitHub Actions or ADO runners, right? And they can all use the common image library, which is the same library that you can use it for game workstations as well as for build test farms. We will all see this in a quick demo as well. It's not moving.
There we go.
All right. There are some of the accelerators that we have enhanced for game build test. For example, AZ Copy is a very fast copy tool that we have enhanced for game build copying. It now uses MD5 hash instead of last modified time, because every time you build games, all the files gets updated, at least from the time perspective, but really 99% of the files don't really get updated. So you use that capability. We have a private ADO extension that can interact with Perforce, and when there is a change in Perforce code, it actually spins up the build test pipelines. And we talked about Perforce, and then also Incredibuild, one of our partners, have built capabilities around build test on Azure. So combining Azure Virtual Desktop, the capabilities of game development, and also build test farms, using source code systems across the globe, all using one management console, you are now able to distribute these aspects across the globe, right? So now the developers can be remote, any part of the world, interacting, on Azure. I think, when all those components are on Azure, then the amount of time that you are spending in terms of moving the content across different systems becomes significantly lower. Okay. Now we talked about game development, build test farms. Now let's talk about game services and servers as well. So on Azure, which is a pretty common use case for game publishers to host games, right? You can publish games on Azure Virtual Machines or on Kubernetes, which is managed, or AKS. And then, as John mentioned, PlayFab as well offers game server hosting capabilities. We will concentrate on the first two in our demo as well. This is a high-level architecture on how you can host games today. As you can see, we offer both the platforms as well as PlayFab. We take care of load balancing in terms of managing, opening the firewall ports. So you could have a matchmaker service anywhere, even on-prem or different cloud providers. And then we offer from entry point from DDoS, up to managing the backend connections and database services as well. Right? It's pretty common for our customers to actually expand their on-prem build, game server farm to Azure, and then scale back down because of the pay-as-you-go, capability of, you don't need to pre-provision these instances. In terms of game services, this is a pretty common three-tier architecture, right? It's not as complex as game servers, but you still need to make these services globally available. So you see Azure Front Door, API Management, AKS, Azure Functions, Cosmos DB, some of the services pretty commonly used across the globe. Several industries use these to build those game services architecture. Okay. We'll do a quick demo of some of those capabilities that we talked about. All right, so you might have seen this. This is Azure Portal, right? So I've created a resource group here, and then I've created certain resources. So this is a resource here called as host pool. This is part of Azure Virtual Desktop. And it's a pretty straightforward process to create a host pool. A host pool is created, for example, if you have a set of developers in, say, West US and in East US. So you create two host pools, right? One for each region. You say what virtual machines you need. You select an image, and then you actually bake an image and then use that image to create these host pool instances or workstations, right? So one important aspect to remember on Azure Virtual Desktop, you don't pay for any of those overlay services, right? You actually pay for the compute, storage, and network, so very similar to an Azure virtual machine. And we don't restrict any virtual machine size or family. You can use any of them underneath Azure Virtual Desktop. So in all aspects of maintenance, management, is just a virtual machine underneath. So here I have a host pool with one virtual machine here, and I've connected to that remotely, and here is mine, and you can see some of the common tools. I have installed a game engine here, and this is all coming through a common template that I've enabled here. If you can see, this is the script that I was showing earlier as well. Some of the tools that I have said that I need to have these in my image, and I'm creating this image on demand, and then I'm building that host pool with those workstations. Right? You can see here, I'm using Chocolatey to install Visual Studio Code, .NET extensions, SDKs, and you can see those all installed within this virtual machine as well automatically. Right? You can see the times to match them, and then if I launch, for example, I've Unreal Engine here, which is one of the common game engine platforms. And I'm seamlessly able to interact with my project, right? With almost no latency or jitterness. And then again, you can just scale this out through automation, through Terraform, through Azure native scripts, and you can scale back down. And you can also set policies such as start on click, so that game developers just have to come in the morning, start on the click button, and then it immediately starts these workstations up. Yeah. And coming back to game builds, right? So this is an example of scale set, where now I've created a scale set with my build test image. I can use Spot VM, so you can see here I have a 100% Spot VM, so I can put a mix as well. Then I can configure it to let's say 50 VMs, right? So it should immediately start scaling out. And again, once you can automate this as well, part of your build test automation pipeline, so that these are created, scaled out and scaled back in almost on an instantaneous fashion. Yeah. So we'll wait for that to come back up, so you can see there already those 50 VMs have been created, right? And then in terms of game server hosting, here is a simple YAML file that I'm using within my AKS, which is essentially Epic Games Lyra server, which is a starter game. I packaged it and put that in an Azure Container Registry. You can see that image as well. And then I'm exposing on port 7777. And then if I go back to kubectl, and then so I have 3 nodes, as you can see, and all these nodes have public IP addresses. So this is very typical in a game server hosting deployments, where you'll see public IPs attached to those. So you would connect to the public IPs and the pod's port number, right? So I'm using a command to find that port number. So in this scenario, it is 45291. I'm using one of the pods. And if I head back to my Azure Virtual Desktop, which is a game developer workstation, I've also created or have a game client running there. So I'm just going to connect to one of those ports. There you go. So in a way, it's very seamless manner, able to connect to those game servers that are running within my Kubernetes cluster, and then also play a game from my Azure Virtual Desktop, using simple remote desktop, right? There's no expensive software here to interact, and you can see it. It's pretty seamless as well, and the experience is very realistic too, right? Yep, I think that's about it from my end. Thank you so much, and please feel free to ask any questions after the session. Thank you.
Awesome. Thank you, Tapa. So shifting gears, we talked on the far left and the far right, essentially, of two use cases so far: game development, build, CI/CD in Azure, and then also game servers and services, connecting close to your player with the global distribution of Azure data centers. Want to shift gears now as we dig through a couple of these slides I think Utapa shared. Just a real life example. So very sad, we actually did this talk at GDC, Game Developers Conference, a couple months ago, and we're very fortunate to have Kate Rayner, CVP, Technical Fellow for the Coalition and Xbox Game Studios, essentially bring this all to life and speak to how the Coalition is essentially achieving this vision. They're maybe one of the closest AAA game titles and game studios that are achieving this kind of end-to-end vision in Azure. This is a quick overview, essentially, of their entire environment at a glance, how they're doing identities, configuration, profile progressions, leagues in Azure, using Azure Kubernetes Services. Orleans is their framework. They obviously leverage Xbox Live. They leverage PlayFab for a few things as managed services. And on the far left there, you'll see their kind of infrastructure environment from before, which was entirely on-prem and had a lot of challenges with things like giving access to contractors, right? There's contractors all around the world that are working on your game. It's hard to get them secure access to your game. But now that they're using Perforce in Azure and a new kind of Azure-based infrastructure, it's a lot easier and a lot more secure. So shifting gears and moving now to, I think, the topic that I'm sure a lot of y'all were excited for and is certainly the most sexy part of the conversation today. We have AI in gaming. I'm going to pass it over to Dan here in a moment, but of course this is that middle box of how you can basically sprinkle in AI services to help enable this end-to-end vision, to accelerate the game development cycle, automate processes, and create really cool experiences for your gamers and players as well with AI features in the game. Especially with the announcements this week, I think this is a groundbreaking week for game development with what was shared with Copilot plus PCs, Phi 3 and small language models running locally on your PC now. Essentially gives you the ability to not have to consistently tap into Azure cloud services every time you want to access a large language model. You can do it locally on your machine, which is a lot cheaper and more cost effective. So I think we're about to see an explosion in AI features in games in a really, really exciting way. And we'll talk about some of those use cases today. We're also going to be talking a little bit about building custom Copilots today. I want to make sure to clarify, you all know of Copilot and M365 and Power Platform and Windows. You know about our Copilot extensibility story. I'm sure you heard a lot about that this week with Copilot Studio, build your own low-code Copilots. Really, we're going to be focusing on the right side today, building custom Copilots with Pro Code, Azure AI Studio for leveraging and accessing any models you want, including small language